Yes, good morning everyone. Today our topic is based on the conditions for fz to be constant. Here are some exercises in that we will prove that under what conditions fz can be a constant in D. So to start with, there is the first question. Let fz be an analytic function in a domain D if f dash z vanishes identically in D. Prove that fz is constant in D. Now to prove this fz to be constant, we have given that f dash z vanishes. Vanishes means this derivative of the function will be 0. So to start with the proof, let we take fz to be equal to u plus iota v. In all the questions, we take the help of the CR equations to prove the function to be constant. Now, if I derivate f dash z, then I will be getting del u over del x plus iota del v over del x. This is further equal to, using CR equation, this del u over del x is equal to del v over del y. In terms of v, I am writing minus iota, this del v over del x is minus del u over del y. Since f dash z vanishes, so this function is 0. That is, this equation is also 0 and this equation is also 0. Now, if you look this 0 as 0 plus iota 0 and equate the real and imaginary parts in both the equations, you will be getting, equating real and imaginary parts, we get this u is equal to curly u over curly x. I'm using the word sometimes curly, sometimes del, so don't confuse with that. These both are one and the same thing. Alright, this is del u over del x is equal to 0 and del v over del x is 0 from the first equation. From the second equation also I get del v over del y is 0 and del u over del y is 0. Now if the derivation of a function is 0, then this function itself will be constant. So from here, u and v are constant. This implies fz is constant because fz is u plus iota v, so fz is also constant in domain D. Hence the proof. Okay, next one. Suppose fz is analytic in a region D and assumes only real values. What does that mean? You're having fz to be equal to u only. Here v is 0 because it assumes only the real values. Then fz is constant. Now what is your fz? This is u plus iota v, we know that, but it assumes only real values. Fz assumes real values. So the imaginary part is 0, that is v is 0 here. Your function fz is equal to u only. Now assumes only real values. Okay, so if fz is equal to u, now what you will get then, v is 0. Okay, if v is 0, then curly v over curly x is 0. Also curly v over curly y is also 0. If I use the CR equation, I will be getting from this If curly v over curly x is 0, then curly u over curly y with negative sign, this is also 0, implies curly u over curly y is 0. Similarly, if curly v over curly y is 0, then del u over del x is 0, implies del u over del x is 0. So by using the CR equations, I get the result for partial derivatives for u to be 0, which implies u is constant. If u is constant, then fz is also constant. So fz is constant. Hence the proof. Next. Let fz be analytic in a domain D. If real part of fz is constant in D, prove that fz is constant in D. Now here the real part is constant. So let f of z is equal to u plus iota v. Now here the real part is constant. So we say that u is constant. Now if u is constant, then the derivative with respect to x is 0, and also derivative with respect to y is also 0. From this, using CR equation, if del u over del x is 0, then del v over del y is 0. And from this, I am neglecting the minus sign because it is equal to 0. So this is del v over del x is 0. Okay, I am using the minus sign so that you are not confused with the CR equation, which further implies del v over del x is 0. So from this two result, I will get v as constant. If v is constant, u is constant, then fz is constant. Similarly, if it is given that imaginary part of the function is constant, then you will take v to be constant and using the CR equation prove u to be constant. Both the functions are constant and you will get fz to be constant. So this is the exercise for you. Let fz be analytic in a domain D. If imaginary part of fz is constant in D, prove that fz is constant in D. So do it yourself. Okay, the last one, let mod of fz be constant in a region where fz is analytic, then fz is constant. So it is given now that mod of fz is constant. So let f of z is equal to u plus iota v. What is mod of fz? This is u square plus v square. Now, if mod of fz is constant, take this to be is equal to c square, where c is constant. So, if c is constant, then c square is also a constant. So, you are having the equation u square plus v square is equal to c square. Differentiating partially with respect to x first, take this equation as 1. I am differentiating this with respect to x first. So I will be getting 2u del u over del x plus 2v del v over del x is equal to 0, which implies cancel out this 2, you get u del u over del x plus v del v over del x is equal to 0. Now multiplying the whole equation with respect to u, you get u square del u over del x plus uv del v over del x is equal to 0. Take this equation as 2. Similarly, if I differentiate partially with respect to y, again differentiating partially with respect to y. What I will be get? This is u. Del u over del y plus v. Del v over del y is equal to 0. Now I am multiplying the whole equation with respect to v. Okay, wait. If I use CR equation here, I need this partial to be in the terms of u only. So instead of curly v over curly x, can I use a CR equation to use here curly u over curly y? So this is curly v over curly x. Take this in terms of u only, curly y, because using CR equation this sign will change, this will be minus. Okay, now I'm multiplying. Before multiplying, I'll also change this. I take this v to be changed in u. So this is curly u over curly y plus v. Curly v over curly y becomes curly u over curly x is equal to 0. Now multiply the whole equation with respect to v. uv curly u over curly y plus v square curly u over curly x is equal to 0. Take this equation as 3. Now for my second equation is also in terms of u with respect to their partials, and third equation is also in u with respect to its partial. Now if I add second and third, this term and this term will cancel out. uv and negative uv, this cancel out, and I will get u square plus v square. Now adding 2 and 3, I will get u square plus v square into del u over del x is equal to 0. That is, this implies either u plus v square is equal to 0 or del u over del x is equal to 0. If I take the first case, if u square plus v square is 0, this implies u and v both are 0. u is also 0 and v is also 0. This implies your function fz, which is equal to u plus iota v, this is 0. That is, your function is constant. Now the second case, if del u over del x is 0, then in this case, if del u over del x is 0, this implies if I use the CR equation, then del v over del y is also 0. Okay. Now similarly, if I get the result del u over del x is equal to 0 by adding 2 and 3, then I will get the result similarly del v over del x is equal to 0 if I subtract second and third. In that case, what you will do, same procedure hai. You will differentiate with respect to x like this. Then using the CR equation, you convert whole equation in v. Use here now CR equation instead of this and multiply the whole equation with respect to v. I multiplied it with u, you multiplied it v. Now in the second one also, you use CR equation over here and add the equation with respect to u, and then you subtract both this. You will get the result as u square plus v square del v over del x to be equal to 0. You will get this on subtracting. Now you You have proved this on adding this, so you can similarly write, similarly we get, if on adding I get this equation, then similarly you just write, you don't prove again and again, you just write similarly we get del v over del x to be equal to 0. Don't prove this again. So this implies if del v over del x is 0, then del u over del y is also 0 using the CR equations. So my all the partials are 0, so which implies u and v are constant, which further implies f of z is equal to u plus iota v is also constant in domain D. Now, in this question, I have used the word region. Let mod of fz be constant in a region. If I use the word circle instead of region, then your function may not be constant. Here is an example I am explaining. Just check the remark again. The word region cannot be replaced by circle. Why? If I take an entire function zn, then this function will become z the power n. Now this function is not constant, but if I take the mod, it has a constant modulus on every circle centered at the origin. Suppose I take the circle to be a unit circle, then this function is equal to z. Here n is equal to 1. Now if we take the mod f of z, that is equal to, okay, if you take z the power n, then this mod, this is equal to mod of z the power n. We have mod z is equal to 1, so I write this as 1. Now you see that this mod of fz is equal to 1, that is modulus of the function is constant, but the function itself is not constant. Whether modulus is constant, but the function itself is not constant. In case if I write or replace this region word with the word circle. But in the previous question, I have used the word region here, and my mod of fz is also constant, and in this case function is constant. Function is proving to be constant because here it is based on the region. This function mod is constant in the region. But if I consider a circle, then may the mod of fz is constant, but the function itself is not constant. In case of circle, function is not constant, but mod is constant. So this is a big difference in both the words circle and the region. All right. So in the next class, I will be taking the questions that are based on the limits, and I will take two functions, that is fz and gz, or then I will do the exercises or discuss them in case their limits exist or not. So after that, I will be taking the exercises that is based on the harmonic functions and some of the simply connected regions too. So do subscribe for more videos that are based on the analytic functions. So thank you.